All right. Hey again. Um, we are going to be reviewing some linear equation knowledge. This is again to help you with the individual work. You'll also see on your individual work, if you haven't at this point, or the page in the ebook, that we actually have notes that are pre-written. I'm taking those notes more or less every time and then adding a little bit into there to really clarify some concepts that might be breezed over. So if you feel really strongly about this stuff, you want to get the notes done, these are not necessarily required video. It's not required to look at these videos, but it is really helpful to really understand exactly why things are the way they are, as well as reviewing some concepts that build up towards these more difficult lessons. So today we're going to take a look at linear equations, quickly review the few different kinds, and then actually take a look at a new form that will help out with some of these individual word problems. So linear equations, we've been talking about this since Algebra 1, even before that a little bit. And so a linear equation is defined as any function with a constant rate of change. And so what that means is that if you increase your x by a value, your y value is going to change by a corresponding number. That value is always going to change, so say I increase my x by 1, my y will always increase by 3 every single time I increase my x by 1. There's a few ways to define this. First, we had probably the most well-known one, slope-intercept form. And so that was our y equals mx plus b idea. So y equals mx plus b. And so we had our slope. So m equals the rise over the run. So the rate of change, that's why we say it's constant. As well as our b, our y-intercept. So if we wanted to take a look at what these values look like in terms of a line on a graph, well, if we're looking at our line, say like so, we can actually use the y-intercept, the value of y when x equals 0, as well as the slope, or the rise or the run, the ratio between the rise and the run. So we got a run and a rise, so that we can actually determine what our slope is and what our y-intercept is. So a good example of this would be something like y equals 3x plus 2. In this case, we have a slope of 3. Remember, this can be shown as a fraction, 3 over 1. And then our b, our y-intercept, is just this 2. So if we wanted to graph something out with all of this, well, we just need to create 2, 3, 4, 1, 2, 3, 4, 5, 6. 3, 4, 5, 1, 2, 3, 4. We actually need to define our y-intercept, so it's going to start off at 2, and we know that every time we step over one step in the x-axis, in the x direction, the horizontal, we're going to increase by 3 in the vertical. So we go over 1 and up 1, 2, 3 to get to our second point. At this point, we have enough information in order to draw that line, which is going to look something like this. Okay? So the second relevant value or equation that we want to talk about is the point-slope form. So the slope-intercept is important because it told us, okay, if we have our slope as well as our y-intercept, or the value of x or y when x is 0, we can figure out what this line looks like. point slope form is great if we have any point on here as well as the slope. So notice how we don't have to have that y-intercept anymore. So we know this as y minus y1 is equal to the slope m times x minus our specific x value, x sub 1. In other words, this is saying I have an x and y value anywhere on the coordinate plane. I know the slope, so I can actually put this together. If we have our x1 equal to 0, notice how if we move our y1 over here, we actually get our slope-intercept form back. So just a general form, we have our coordinate plane, we have a single x and y point, and we want to figure out what this line looks like. So we can look at our run, and this time I'm going to make the rise negative, so we're going to go downwards a little bit. And so that'll get us our second point, which we can then use to define our line. Okay. So good example for this, maybe y minus 2 is equal to, let's say, negative 2/3 times x minus 1. So for this specific value, this specific case, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so for this specific value, we know that our y coordinate is 2, our x coordinate is 1. Remember, it's separate from the negative sign. So if we have x plus 1, then we would have a negative 1 as our x value. Same with the 2. If it was plus 2, then we would pull out a negative 2 for our y value. So we start off at over 1 up 2. So y1 is equal to 2, x1 is equal to 1. So I've got 2, 1. We use our rise over our run. We know we step to the right 3 spaces, 1, 2, 3. And then downwards 2 spaces to get our second point. And there we have it. We have our line where instead of using our y-intercept, we can use any single point. So what the math notes kind of go on to say is that we have something called the graphing form. And so this is kind of an updated version of the point slope form. We're going to bring this y value over, and we're going to change the notation up. So if we decided to add y1 to both sides, then change our x1 point to h, our y1 point to k. This should look pretty familiar from last year where we used a lot of shifting. We can actually define our graphing form to be y equal to our slope times x minus h plus k. So this one's really nice because we can actually start talking about shifting functions. So if we wanted to start off with maybe y equals 2x, we could graph that and then use our more complicated expression to show that shift. So I'm going to flip this over, do a specific example of so. And actually this one's going to draw from the homework problem. So this one is talking about, let's see. find maybe not find. Graph the function using a shift So what I mean by that is if I want to graph out the equation y equals 1/2 times x minus 4 plus 3, I can do this in two ways. I could put in a bunch of x's, make my xy table. So way one, make an xy table, choose a bunch of x values, run it through to get all our y values, and hopefully we get something that looks like a linear equation. That's pretty complicated given our function. Second way we can do this is actually look at what's called the parent function, which is just the slope with the x. It doesn't take into account the horizontal shift, this h, or this vertical shift, this k. So start with the parent function. Don't bother with this 4 and 3 yet. Why don't we simplify it down to y equals just 1/2 x. And that's pretty easy to graph out. And I'm going to do it nice and big here so that we can clearly see how our equation, original one that we're looking to graph, corresponds to this 1/2 x that we created. 4, 5, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then 3, 4, 5. Awesome. So we're doing this parent function. I'm going to box this in blue so we can really see which one is which. So this 1/2 x, it's saying start at the origin, 0, 0, because our plus b here is plus 0. We're going to step over 2 spaces and then up 1 space, okay, to get that second point. So this is just graphing this out as we did with slope-intercept form, except now our y-intercept is at the origin. The y value is 0 when the x value is 0. So from here we can actually, instead of going through all of this, notice, hey, well, the h and the k is telling me shift horizontally 4 spaces. That's every single point. And the k is saying shift vertically. Three spaces. And so it's really important to pay attention to how our original equation x minus h plus k, we don't want to include these signs. So if we're looking at our specifics, we pulled out that 4 to keep that same form. So we're going to go to the right 4 spaces and then up 3. So each of these points. So this one's going to go over 4 spaces and then up 3 spaces. 1, 2, 3. So that's going to be one new point on our line, and then we're going to do the same thing right here. We're shifting over that second point. 4 spaces, 3, 4, and then up 3 spaces. So that's going to be 1, 2, and 3. Okay. So here's our next line. So if my drawing was all perfect and good to go, we would actually have a very parallel set of lines. Obviously, I'm not the best artist, but this is actually going to give us our fully shifted equation. Okay, so we're going to be focusing on these shifts a little bit, getting more and more used to seeing them, being able to see a linear equation and knowing how to describe the similarities and the differences. So notice the similarities between the two is that they have the same slope. the whole difference is, well, they have different y-intercepts. They're two different lines. They're never going to intersect. So just some good things to look out for in the individual work. Let me know if you have any questions. You can get those answered.